Hi, this is Professor Sartor, and today we're working on practice test 2 and questions 21 through 30. This practice test covers chapter 3 and 4. The first question says, use the graph to evaluate the given expressions or state that it is undefined. Part A, what is the value of f plus g of 4? Before we start working this out, let's make sure we understand this notation. We have f plus g of 4. The f plus g part is the name of the function, but not only the name, but how the function is constructed. You have some function named f and some function named g, and you construct f plus g by adding f and g together. So to start working this problem out, we're going to rewrite the original problem based on this definition here. F plus g of 4 is the same thing as f of 4 plus g of 4. Now we can work out these individual expressions. F of 4 means that the x value is 4, and we're looking for the y value in the function called f. So let's go over to this graph, and we've got two curves. One of them is labeled f, this red one is labeled f, and the blue one is labeled g. So if my x value is 4, and I walk my way up to the function, I can see that the y value is 2. So f of 4 is 2. Then I can do the same thing with g. My x value is 4. I walk my way up to the function, and then I can go over to the y scale to get that y value of 3. Then you're going to add those two answers together. Because this function is f plus g, that's why we're adding those two together to get 5. So f plus g of 4 is 5. Part B. What is the value of f minus g? So just like the previous example, f minus g is the name, but also how the function is constructed. We're going to take the function called f and subtract the function called g. So we can rewrite this as f of negative 4 minus g of negative 4. We can figure out those values from the graph. F of negative 4, the x is negative 4. I'm going to go up to the graph of f and over, and we've got a y value of 2. Do the same thing for g of negative 4. We have g of negative 4, go up to that y value, and over, we have 1. G of negative 4 is 1. Then we're going to subtract those two values, and 2 minus 1 is 1. So for part B, f minus g of negative 4 is 1. Part C, what is the value of g times g of 4? So g written next to g is multiplication, g multiplied by g. So we're going to rewrite this as g of 4 times g of 4. We're going to use our graph. So we have an x value of 4. We're going to go up to the graph of g and over, and we've got a y value of 3. So g of 4 is 3. G of 4 is 3. We're going to multiply those answers together to get 9. Part D, what is the value of f over g of 4? So let's rewrite that as f of 4 divided by g of 4. We're going to use the graph to figure out what f of 4 is. For my x value of 4, go up to the graph, and I've got a y value of 2. So that goes in the numerator. G of 4, have x value of 4, go up to the graph and over, have a y value of 3. That goes in the denominator. So f over g of 4 is 2/3. For this example, we have, for the pair of functions defined, find f plus g, f minus g, f times g, and f divided by g. Give the domain of each. So our functions, f of x equals x squared minus 4, and g of x equals 3x plus 9. First thing we want to find is f plus g. So the name is exactly how we do it, how we construct it. F plus g of x is the same thing as f of x plus g of x. And f of x is x squared minus 4, and I want to add that to 3x plus 9. Then we want to simplify by combining like terms. That would give me x squared plus 3x plus 5. So f plus g is x squared plus 3x plus 5. Then it says, find the domain of f plus g. So we need to go back a little bit and first think about what is the domain of these individual functions. So for f is x squared minus 4, and x squared minus 4 is a polynomial function. So that's going to have a domain of -infinity to infinity. And g of x equal 3x plus 9 is also a polynomial function, and it'll have a domain of -infinity to infinity. When you take two polynomial functions and add them together, it creates another polynomial function, which has a domain of all real numbers, or -infinity to infinity. So that is the answer for domain of f plus g, -infinity to infinity. So moving on to the next part, we want to find f minus g of x. F minus g of x is f of x minus g of x. F of x is x squared minus 4. And I want to subtract g of x. Notice I'm putting parentheses around g of x to make sure I'm subtracting the whole function. And when I simplify this, I need to distribute that negative sign. Make it minus 3x minus 9, and then combine like terms. That would give me x squared minus 3x minus 13. So that is f minus g. And then we want to find the domain of f minus g. So just like the previous example, when you take two polynomial functions and you subtract them, you're going to create a new polynomial function. So the domain of that function will be -infinity to infinity as well. The next part is f times g of x. So f times g of x is the same thing as f of x times g of x. So that's going to be x squared minus 4 times 3x plus 9. Notice I put parentheses around both of those because I want to multiply the whole function f times the whole function g. And now we're going to multiply that out with the FOIL method, or if you have another method of multiplying you like, you can do it that way. So that would give me 3x cubed plus 9x squared minus 12x minus 36. There are no like terms there, so this is as far as we can go. On the next part, we want to find the domain of f times g. Just like the previous examples, when you take two polynomial functions and you multiply them, that's going to create a new polynomial function, and the domain is negative infinity to infinity, or all real numbers. The next part, f over g of x. F over g of x is the same thing as f of x over g of x. So I'm going to have x squared minus 4 in the numerator and 3x plus 9 in the denominator. When you simplify expressions like this is a rational expression, you want to factor and see if there are any common factors that you would cancel out. Your numerator here can factor, it's a difference of squares, x plus 2x minus 2. Your denominator, both of these terms have a common 3, so I can factor out a greatest common factor of 3. So we get 3 times x plus 3, and I notice that there are not any common factors, so this is as far as you would need to go. It is in lowest terms or simplest form. The next part says find the domain of f over g. So this one is different than the previous examples. In all three previous examples, adding, subtracting, and multiplying created another polynomial function. But when you divide two polynomials, you don't create a polynomial function, you create a rational function. With rational functions, we're worried about the denominator being 0. So to find the domain, we're going to take that denominator of 3x plus 9, set it equal to 0, and solve. So we're subtracting 9 on both sides. We get 3x equals 9. 3x equals 9. We'll divide by 3 on both sides and get x is equal to 3. The value of x equals 3 is going to cause the denominator to equal 0. And when you divide by 0, that's something that's undefined. So we don't want the value of 3 in our domain. It has to be excluded from the domain. So if we're thinking on our number line, we would mark 3 on our number line. That value is excluded, which is why I wrote it with an open circle, but we're going to include every other number on the number line. So using this picture, we can draw the interval notation. I want to draw an interval for the left side here, the shaded region on the left side. That goes from negative infinity to 3. And I want to write an interval for the right-hand side, the shaded region. That goes from 3 to infinity. And I'll put the union sign between those two. So that's our domain of f over g. Negative infinity to 3, union with 3 to infinity. This example says find f of g of x for the indicated functions and simplify. We're given f of x is equal to 3x plus 2 and g of x is equal to 8 over x plus 2. This operation, f of g of x, is called composition. And what it means is substituting one function inside of another function. Let me rewrite this. F of g of x means that you're going to substitute g inside of f. So the inside function is always the function that is second or after the composition symbol. The outside function is the one that's before the composition symbol. So we're going to substitute g of x inside of f of x. g of x was given as 8 over x plus 2. So that's what I'm going to be substituting in for f. Everywhere I see an x, I'm going to replace that x with 8 over x plus 2. So that's 3 times 8 over x plus 2 plus 2. I can simplify this by multiplying. The 3 is the same thing as 3 over 1, and that would give me 24 over x plus 2 plus 2. This example says evaluate the expressions in A through F using the graphs y equals f, f of x, and y equals g of x shown below. So we have two graphs. This one's labeled g of x, and this one's labeled f of x, and we're supposed to use these to help us answer the questions that are over here. So if we take a look, part A says g of f of negative 1, and really we just need to follow the symbols to work these problems out. And we're going to sort of act like we're doing order of operations. We do what's on the inside first. So on the inside of this expression says f of negative 1. If we keep in mind that the negative 1 is the x value, so I'm going to go over here on my graph to where x is negative 1, go up to the graph of f, and what is the y value there? The y value there is 2. So I've just worked out what f of negative 1 is. So g of f of negative 1, and f of negative 1 we worked out to be 2. So now I have the symbols g of 2. Now that 2, it was a y value for f, but now it's an x value for g. So I'm going to go to where I have an x value of 2, go up to the graph of g, over to the y value, got a y value of 4, so this is going to equal 4. Okay, let's try the next one. So the next one says f of 0. So like I said before, we're going to follow the symbol starting on the inside. F of 0, that's what we're going to work out first. Let me rewrite this. F of 0. I'm going to an x value of 0, going up to the graph of f, and I'm at a y value of 1. So I worked out f of 0 to be 1. Now I want to work out what f of 1 is. Here's an x value of 1, and I'm already on the graph of f. That's a y value of 0. Let's try the next one. We have f of g of negative 1. F of g of negative 1. We're going to work out that g of negative 1 first. So negative 1 is right here. We want to go up to the graph of g, and we get a y value of 5 there. So g of negative 1 is 5. And now we want to find f of 5. So here's an x value of 5, and I'm already on the graph of f. Got a y value of 0 there. So that's 0. F of 5 is 0. F of g of negative 1 is 0. Let's try the next one. G of 4. G of 4. Starting on the inside, we're going to find g of 4. Here's an x value of 4. We go up to the graph of g, and we get a y value of 4. Now we want to find g of 4. We have an x value x value of 4, we go up, and we get a y value of 4. So g of 4 is 4. G of 4 is 4. Let's try the next one. The next one is f of g of f of 0. F of g of f of 0. Starting on the inside, I'm going to do f of 0 first. X value of 0, go up to the graph of f, and we get a y value of 1. So I'm replacing that f of 0 with 1. That gives me f of g of 1. So still working on the inside, we're going to do g of 1. From an x value of 1, we go up to the graph of g, and we get a y value of 6. G of 1 is 6. F of 6. X value of 6, go up to the graph of f, and we get a y value of 1. F of 6 is 1. So f of g of f of 0 is 1. Let's try the next one. The next one is g of f of g of 4. G of f of g of 4. Starting on the inside, g of 4. So we have an x value of 4. We'll go up to the graph of g. We get a y value of 4. That's g of f of 4 now. Have an x value of 4. We're going to go down to the graph of f. That's a y value of negative 1. Now we need to find g of negative 1. An x value of negative 1, we go up to the graph of g and get a y value of 5. So g of f of g of 4 is 5. This example says, write an equation for the inverse function and then state the domain and range of f and f inverse. Our function is f of x equals cube root of 7x minus 3. There's a 3-step process we can go through for finding the inverse of a function. So let me write f of x equals cube root of 7x minus 3. And the first step in the 3-step process is to change this f of x to y. Just a little bit easier to work with the symbols when you have just the y. The next step is to switch the x and the y. And this step right here is sort of the crux of why this method works, because inverse functions have the x and y values switched. So by us switching them, we're now creating the inverse function. The final step in this process is that we now want to solve for y. We want to get y by itself on one side. So I've got to get rid of all this other stuff. I've got to get rid of this cube root, the 7, and the minus 3. The first thing we're going to get rid of is the cube root. So we're going to get rid of that cube root by doing the opposite of cube root, which is cubing. So x cubed on the left, and on the right, I am going to cube this whole side. So nothing to do on the left. On the right, the cube root and the cube cancel each other out. So we're left with 7y minus 3. So we're still working to try to get that y by itself. So then I'm going to get rid of this minus 3 by doing the opposite of subtracting 3, and that's adding 3. You're going to x cubed plus 3 on the left, and on the right, the minus 3 and plus 3 becomes 0, and it cancels out from that side. We're still trying to get y by itself, so we're going to divide both sides by 7, and that gives me y equals x cubed plus 3 over 7. And now that we've gotten y by itself on one side, we have the inverse function. So I'm going to write that as f inverse of x is x cubed plus 3 over 7. So we found the inverse function. So let's go to the next part. The next part says the domain of f is, so looking at the original function, I want to put this function in a category. The categories you should be thinking about are polynomial, rational, and root. Because this one has a radical, this is a root function. And once you decide that it's a root function, you want to pay attention to the index on that radical because you find the domain differently based on whether that index is even or odd. So because this is an odd index, what we know is that the domain of odd index radicals is all real numbers. So the domain of f is negative infinity to infinity. Now that we found the domain of f, we've also found the range of f inverse. Remember, the x's and the y's get switched. So because we know the domain of f, we have the range of f inverse. So I'm going to skip over finding the range for the moment, and let's go to finding the domain of f inverse. This is our definition of f inverse, and I want to put this function in a category. Remember, our categories are polynomial, rational, and root. You can see that the root is gone, but we do have a fraction. Even though we have a fraction, there's no variable in the denominator, so this is not a rational function. This is going to be in the category of polynomial because our power is one of the nice powers. And what we know about polynomial functions, about their domain, is that they have a domain of all real numbers or negative infinity to infinity. So the domain of the inverse is negative infinity to infinity. And like I said a moment ago, the x's and the y's get switched with these functions, so this is going to tell me that my range of f is negative infinity to infinity. This example says, given the quadratic function in vertex form, address the following. Our function f of x equals negative 4 times x minus 2 squared plus 4. Part A, what are the coordinates of the vertex? So as the directions mentioned, this is a function in vertex form, and vertex form is f of x equals a times x minus h squared plus k. Our function is written in that exact form, negative 4 times x minus 2 squared plus 4. So the important thing to memorize about this is that the h and the k stand for the vertex. So we really don't have to do any calculation to figure out the vertex. We just need to line up these positions in the function. So the h and the 2 are in the same place, the k and the 4 in the same place. So our vertex is 2, 4. So this quadratic function has a vertex of 2, 4. The next part says, does the graph open up or open down? We can figure this out based on the value of a. Our value of a is negative 4. And because that is negative or less than 0, we know that this parabola is going to open down. So we would answer opens down. The next part, what is the equation of the axis of symmetry? So axis of symmetry. So for a parabola, let me draw an example of a parabola, which I'll erase later. If you have a parabola, the axis of symmetry is going to pass through the vertex. The vertex, remember, is HK. And it's going to be a vertical line that passes through the vertex. So it's called the axis of symmetry because we're going to have a mirror image around that axis. Now I've drawn it so it's kind of right on the y-axis, but anywhere you draw that parabola, let me just kind of draw it in a different spot. If you draw that parabola in a different spot, you have the vertex at HK, and if you draw a vertical line going through that vertex, you're going to get a mirror image on both sides of that line. So that is the axis of symmetry. So notice each time I've mentioned that it's a vertical line that passes through the vertex. So because it passes through the vertex, we're going to use that x-coordinate of the vertex to help us get that axis of symmetry. So our axis of symmetry is a vertical line. The equation of vertical lines is always x equals. And our vertical line is going to be x equals 2 because that's where the x-coordinate of our vertex is. So we have the axis of symmetry being the line x equals 2. Okay, the next part says find any x-intercepts. So let's find our x-intercept. The way you find an x-intercept is by letting y equal 0, and we know that the symbols f of x has the same meaning as y, so we're going to set f of x equals 0. 0 equals negative 4 times x minus 2 squared plus 4. And then I want to solve this equation. I'm going to solve this equation by using the square root method. The square root method has you isolating this square and everything that is attached to that square. So I want that x minus 2 squared to be the only thing on one side of the equation. So I'm going to subtract 4 on both sides. That gives me negative 4 equals negative 4 times x minus 2 squared. I'm going to get rid of that negative 4 by dividing by negative 4 on both sides. That gives me 1 equals x minus 2 squared. So now I've isolated that square on one side of the equation. And the name of the method sort of gives it away. I called it the square root method. And we do the square root to get rid of the square. So we're going to square root on the left and square root on the right. The square and the square root cancel each other out on the right, and on the left, square root of 1 is 1, but I also need to throw in a plus or minus symbol. The plus or minus symbol has to do with the square and square root. We need to consider cases of plus and minus to account for that square root canceling out the square. So plus or minus 1 equals x minus 2. I need to continue solving this by adding 2 to both sides. So now I have 2 plus or minus 1 equals x. The plus or minus is two possibilities, 2 plus 1, which is 3, and 2 minus 1, which is 1. So now we have our x-intercepts of being 3 and 1. So I'm not sure if I'm supposed to write them as ordered pairs or just write them separated by comma. My guess is separating the intercepts by a comma. The next part says find the y-intercept. Okay, y-intercept. Y-intercept is when x is equal 0. So I'm going to find f of 0. Everywhere I see an x, I replace that x with a 0. So negative 4 times 0 minus 2 squared plus 4. Negative 4 times negative 2 squared plus 4. I'm following order of operations. I did what's inside the parentheses first. Then I'm going to apply the exponent. So negative 2 squared is a positive 4 plus 4. Negative 4 times 4 is negative 16 plus 4. Negative 16 plus 4 would be negative 12. So I've got my y-intercept being negative 12. The next part says sketch the graph and use a graphing tool. So I'm going to plot my vertex. My vertex is at 2, 4. I found x-intercepts at 3 and 1. I have a y-intercept at negative 12. And the important thing to remember is that these are not just random points. Our point right here of 2, 4 is the vertex. That is the point where this graph is going to turn around. And remember, we said earlier that this is going to open down, so it's going to turn around opening down. So I'm going to draw a little peak there at that point and then go through the other points. So there's my graph. The final parts are to find the domain and the range. So you could do this by memorization. A quadratic function is a type of polynomial function, and all polynomial functions have a domain of all real numbers. But you could also use the graph to tell you. Taking a look at this picture, if I look from left to right, I can see that this part of the graph is going to continue to move further left and left. So every x value is going to get covered from negative infinity, and because of this arrow, all the way to positive infinity. For the range, I can see that these y values down here are covered, and the y values are all going to get covered up until you get to where that vertex is at 4. So the range is going to go from negative infinity to 4 with a bracket on the 4. That's including the 4. This question says, first rewrite the quadratic function in vertex form by completing the square, then complete parts A through G. So first we want to rewrite using completing the square. So my function is f of x equals x squared plus 6x. So with completing the square, the first two things I pay attention to is whether our function has a coefficient and whether there's a constant here. I don't have to worry about either of these. I do have a coefficient of 1, but we only need to do something if that coefficient is other than 1. And then we set aside the constant. So we don't have to worry about either of those two things in this example. So then we'll get right to the completing the square process. So with the completing the square process, you need to start with the coefficient of the x here. I'm going to do this work on the side. I like to call this the magic number. So you start with that coefficient on the x, then you're going to cut it in half and square it. So that gives me 3 squared, which is 9. So our magic number for this example is 9. And I want to add that 9 to this group right here. But if I add 9, it changes the function. So I need to balance out by doing the opposite, which is subtracting 9. I'm going to focus on this group of terms, and those group of terms can factor, and they factor into something special called a perfect square. So if I factor, I would get x and x, 3 and 3, both pluses. And so the reason why it's called a perfect square is because both of those factors came out to be the same, and you can put them together into that perfect square binomial. So now we can see that it is in vertex form, and that's what you would write for this first part here, x plus 3 squared minus 9. We can also figure out what the vertex is from this vertex form. is f of x equals a times x minus h squared plus k. So if we pay attention here, we've got, minus h. So in the h spot, we have this 3, but notice it doesn't exactly match up. This one has a plus, the other one has a minus. We really have to do the opposite of that 3 there. So our vertex is going to be -3 and -9. So the k part lines up with this -9. So you may wonder why that is. And so here's my explanation. We want this x plus 3 squared minus 9 to match the format, and plus 3 can be written as minus a -3. And now that it matches up, you can see after the minus is a -3. Now, that's a lot to kind of keep in your head, but you can always just keep in mind that it's the opposite of what you see there. So if you see a plus 3, you're going to use a minus 3 in your vertex. If it's a minus 3, you're going to use a plus 3 in your vertex. So our vertex is -3, -9. The next part says, does the graph open up or down? Does the graph open up or down? And we're going to use that value of a to say whether it opens up or down. So our value of a would be 1. A is 1, which is positive or greater than 0. So that means that this parabola is going to open up. So it opens up. What is the axis of symmetry? So for the axis of symmetry, it's going to be a vertical line. And the vertical line always passes through the vertex, so that's going to be x equals -3 for the axis of symmetry. So because it passes through the vertex, we're going to use the x-coordinate of our vertex for the axis of symmetry. The next part says to find any x-intercepts. So you find an x-intercept by letting y equal 0. We're going to let f of x equal 0. And you can you can do either the original function equal to 0, or you can do your vertex form equal to 0. In the last problem, it was in vertex form, so this one I'm going to do in the general form. So to solve this, I'm going to factor. I can factor the greatest common factor of x. That would give me x plus 6, and then I can set each of these factors equal to 0 to get x equals 0 and x equals -6. So those are my x-intercepts. The next part says to find the y-intercept. You find a y-intercept by letting x equal 0. I'm finding f of 0. That's 0 squared plus 6 times 0, which is 0 plus 0, and that's 0. So we have a y-intercept of 0. So now we're going to sketch the graph. That's the next part, sketch the graph. And we want to plot our vertex, -3 and -9 would be about right here. We have our x-intercepts at 0 and, excuse me, let me fix that, -6. And our y-intercept is at 0. So we have a parabola. You remember this vertex is a special point. That's your turning point. We said this parabola is going to open up. So there's our graph. The final parts are finding the domain and range. The domain of every polynomial function, quadratic function, is -∞ to infinity. And for the range is going to start at that vertex and go all the way up to infinity. Those are the y values that are covered by this graph. So our vertex is at -9. So our range starts at -9, -9 to infinity. This example says, use the quadratic function (x squared minus 4x plus 8) to complete parts A through G. Part A. Use the vertex formula to determine the vertex. The vertex formula is h equals -b over 2a, and k is f of h. That's how we're going to find the vertex, hk. So for the quadratic function that we have, a is the coefficient of the squared term, which is -1, b is the coefficient of the x term, which is -4, and c is 8. So to find the x-coordinate of the vertex, we're going to do -4 over 2 times -1. That simplifies to be +4 over -2, which is -2. So we've got our x-coordinate of the vertex. Let's find the y-coordinate of the vertex. Ooh, sorry about that. So let's find the y-coordinate of the vertex. And we're going to substitute the -2 into the function f. So k is going to be f of -2. That's -2 squared minus 4 times -2 plus 8. We're going to simplify following order of operations. I'm going to apply the exponent first. -2 squared is a +4, but we carry that negative down. -4 times -2 is a +8 plus 8. -4 plus 8 is +4 plus 8, and they give me 12. So now we have our vertex being -2, +12. The next part says, does the graph open up or open down? So the A is going to tell us whether the parabola opens up or down, or the graph opens up or down. Since it's negative, less than 0, it opens down. This graph opens down. What is the equation of the axis of symmetry? Axis of symmetry is the next part. The axis of symmetry is a vertical line passing through the vertex. So it's going to be x equals the x-coordinate of the vertex. X equals -2. The next part says find any x-intercepts. So to find an x-intercept, you let y equal 0 or f of x equals 0. So I'm setting my function equal to 0. 0 equals -x squared minus 4x plus 8. I'm going to try to factor this, but I don't like to factor with a negative in the front. So I'm going to divide every term by -1. Get rid of that negative. 0 equals x squared plus 4x minus 8. I'll try to factor. So x and x. 8 is 4 times 2. I don't think that's going to work. So, since we can't factor it, we can use the quadratic formula to solve. So A is 1, B is 4, and C is -8. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I'll substitute the a, b, and c into the formula to get -4 plus or minus the square root of 4 squared minus 4 times 1 times -8 all over 2 times 1. And I'm going to simplify following order of operations. So underneath the radical, 16 squared, 4 squared is 16. A negative and a negative is a positive, and 8 times 4 would be 32. 16 plus 32 would be, let's see, 48. Then I'm going to simplify the radical. 48 factors to be 16 times 3. The reason I factored it this way is because 16 is a perfect square. And I'll be able to simplify that radical. Square root of 16 is 4. And then I want to reduce these three terms have a common factor of 2. So I'm going to divide 2 into each one of them. And that would give me negative 2 plus or minus 2 square root of 3. Those are my two x-intercepts. Negative 2 plus 2 square root of 3 and negative 2 minus 2 square root of 3. X equals negative 2 plus or minus 2 square root of 3. The next part says find the y-intercept. So to find a y-intercept, you're going to let x equal 0. So that's finding f of 0. Negative 0 squared minus 4 times 0 plus 8 would be 8. So we have an x-intercept of 0. Sorry, that's a y-intercept of 8. The next part says sketch the graph. So we're going to plot our vertex first. Our vertex is negative 2, 12. Negative 2 and 12 would be about right here. We have a y-intercept of 8. And I believe with your graphing tool in my math lab, you only need those 2 points to be able to draw that parabola. Then the last two parts, finding the domain and range. The domain is going to be negative infinity to infinity, and the range is going to cover negative infinity all the way up to that vertex. So that's negative infinity to 12 with a bracket on the 12. This question says analyze the graph to address the following questions about the quadratic function it represents. So we're taking a look at this graph, and using this graph we're going to answer the following questions. Is the leading coefficient positive or negative? So because our parabola here is opening down, we know that our leading coefficient, is negative. The next question says, what is the value of h and what is the value of k? We use h, k to stand for the vertex. So the vertex of the parabola is right here. Oops, sorry. Use my highlighter. The vertex is right here, that 2, 2. So we can see that h is 2 and k is 2. The next part says, what is the value of the leading coefficient a? This is going to take a little bit more work to get. So what we have to do is use our vertex form, or our standard form, f of x equals a times x minus h squared plus k. And we're going to use the values in the graph. So we have the 2, 2, which gives us the h and the k. And then we have the second point on the graph, the 9, negative 5. And that's the 9 represents the x, and negative 5 is a y, but we can also use f of x to represent y. So looking over here at our standard form or vertex form, we have the vertex that we're able to fill in for h and k, and we're able to fill in that other point with the x and y, which is f of x, and that only leaves the a left. So once we fill in or substitute those values in, we'll be able to solve for a. So substituting in for f of x, I've got negative 5. A is what we're trying to figure out. In for x, we have 9. H is 2. And k is 2. Now we're going to do a little bit of simplifying. 9 minus 2 is 7. 7 squared is 49. We have a times 49 plus 2, which we can rewrite as 49a. Now we have an equation. We're going to solve for a, subtract 2 on both sides. That gives me negative 7 equals 49a. Divide both sides by 49. And we have a equals negative 1/7. So negative 1/7 is a. The next part says write the equation of the function in vertex form. So vertex form is f of x equals a times x minus h squared plus k. And we're going to fill in the h, the k, and the a that we just figured out. So that's negative 1/7 times x minus 2 squared plus 2. So we have the equation in vertex form. The next part says write the equation of the function in the form f of x equals ax squared plus bx plus c. That's general form. And to write it in general form, we need to take the standard form that we just, standard or vertex form that we just worked out, and just multiply everything out. So we'll start with negative 1/7 x minus 2 squared plus 2. It's negative 1/7 times x minus 2 times x minus 2 plus 2. We'll multiply out that x minus 2 times x minus 2. That's x squared minus 2x plus 4 plus 2. I'll combine like terms to get negative 4x plus 4 plus 2. I'll distribute that negative 1/7 to get negative 1/7 x squared plus 4/7 x minus 4/7 plus 2. And finally, I want to combine those two last terms together. Oops. Let me fix that. So that was 4/7. I want to combine these two constants together. And I need to get a common denominator. It's negative 1/7 x squared plus 4/7 x minus 4/7. I'm going to write this 2 over 1 by multiplying by 7 over 7. That gives me 14 over 7. And now that I have a common denominator, I can combine those fractions together to give me a plus 10 over 7. A baseball player swings and hits a pop fly straight up into the air to the catcher. The height of the baseball in meters t seconds after its hit is given by the quadratic function h of t equals negative 4.9 t squared plus 34.3 t plus 1. How long does it take for the baseball to reach its maximum height? What is the maximum height obtained by the baseball? So I want to highlight a key word for you here, and that is that we are talking about finding a maximum. And I also want to highlight the function that we're dealing with. H of t equals negative 4.9 t squared plus 34.3 t plus 1. So this equation is a quadratic. And what we know about quadratics is that they have graphs that are parabolas. And the parabola is either going to be facing up or facing down. Because of the negative in the front, we know that the parabola is going to be facing down. And if we keep in mind that we are looking for a maximum, the maximum height is going to be at the peak or at the vertex of the parabola. So because our graph is a quadratic, specifically a down-facing parabola, the maximum is going to occur at the vertex. So essentially, we're going to be able to answer this question by just finding the vertex of the parabola. So remember, we have our vertex formula, which is negative b over 2a. So that's going to be negative 34.3 over 2 times negative 4.9. And by typing that into a calculator, we can get that that is 3.5. Then we can find the k by substituting that 3.5 into the function. So we have h of 3.5. That's negative 4.9 times 3.5 squared plus 34.3 times 3.5 plus 1. And if we put that in our calculator, we get 61.025. Says to round to 3 decimal places, so that is the answer. Now, let's make sure we know what these values mean. Typically, the h in the vertex is representing an x, but we don't have an x in our equation. We have time, which is t. So this 3.5 is representing the time, and the time was given in seconds. So this is 3.5 seconds. Then typically the k is a y value, but our y in this equation is the height, h. So this 61.025 is the height of the ball, and that's given in meters. So the ball is going to reach a maximum height of 61.025 meters at a time of t equals 3.5 seconds. So going back up to here, these questions, it says it takes blank seconds, that's 3.5 seconds, for the ball to reach its maximum height. The maximum height obtained is the 61.025 meters.